try to be on schedule more or less. I have now Brandt's, no? Thanks a lot. I have now the great pleasure to introduce you to Urs Marti, who has joined us in 2016 for this news cycle that started. And if it starts to smell a bit in the room, hopefully will not create a fire, but Urs brought a toy. And with that, I pass on to him. He will talk about energy density.
Alex, musst du es nachher glauben? So I'm not sure if you're hearing me, hopefully. So it's a bit loud, I hope it's not running that long. But the reason I'm doing this, you might think, what the hell is he doing? And operating a steam engine here on the stage. And the reason number one is I'm more talented in operating steam engines than doing PowerPoint presentations. The second one is also I'm more talented in doing this. The reason is it is a consequence of the first, because in school I also preferred doing this kind of things instead of my homework. But the main reason is it's about density of energy, and I want to show a bit as an example what it means. Now, you might think this steam engine is, this steam engine is the basis of our modern world, of our lives we have today, because it enabled the economy in the world to have mass transportation for goods and services. And if you might remember the movie Once Upon a Time in America, which is one of my favorite ones because of Claudio Cardinale, but you remember the plot, when you start connecting people with transport, the economy explodes. And this is what happened since the invention of the steam engine. And you might think, now the steam engine is obviously something from the old days. I think it was invented in 1760, and I think the first trains were running around 1820. But you're wrong, because today, out of the electricity we produce, 80% is still done the same way. It's done with steam. So, and out of this 80%, the majority is with coal, gas, and nuclear fission. The remaining 20% of the electricity is mostly produced with hydropower. And the reason this is being run with coal, why hasn't the industrialization not happened earlier? Because, or with biomass. I think the human beings discovered fire in, I don't know, nobody knows, 300,000 years ago. And in Switzerland, why did we run steam engines with coal? Definitely we don't have coal, but we would have had forests, probably the only thing. Why didn't it work to run these things over the Passo del Gottardo? The problem would be that the fire would also have been gone very fast, which was actually the case 300 years ago, because it was all cut down for building ships and so. But if you look at the steam engine, and you produce steam, it has to be narrow, because you have the tracks, you're running around, you need tunnels, etc. So you can't have the place for the fire is limited here. The boiler is very small and thin, so you have a very limited space where you can make a fire. And this steam engine was run with one of these tablets, which is made from a methanol, which is alcohol. It's a pity to burn it, and nitrogen. So if you put the same amount of wood below that, it wouldn't work, because you would never get enough firepower for getting enough steam. And this is what density of energy is about. So you would not be able to work these things with biomass, which is actually ridiculous anyway, because you're putting pure natural gas in the form of fertilizer into the ground, and then you burn now, or try to burn some cow dung for making steam. But it's a nice graph which shows you how much energy you have to invest in, or the whole hassle you have, and what you get out. And you see the most dense material on Earth is nuclear, and then comes hydropower. I mean, hydropower, you can feel it if you stand below a waterfall. When China opened the Three Gorges Dam, which is the biggest in the world, I think it was 30 years ago, might be wrong, it produced 15% of all electricity for China, just one hydropower station. And then you see it goes down, and to these modern things which we now try to adapt, which is obvious it doesn't work, at least not to the degree we want. And now these discussions about, you might have seen the wind energy because of the cost inflation and the interest rates is not economic anymore. That's like mining, no? If you have a very bad grade and a very poor return and margin, and if the cost is going up, which happens usually for gold or precious things, your return is destroyed. If you have a nuclear power plant, it doesn't matter what the uranium cost is, because it doesn't cost you anything in relation to the total capex. And it's not by coincidence that we obviously have the right-hand things which runs the modern world. I mean, this might be good or not, but this is a fact. And this is maybe a funny equation. So if we take Gösgen winter day, Gösgen produces around energy for, I think, 40% of the household or 15% of total energy in Switzerland, electricity, not energy, because in every country 2/3 is the industry which uses it, not the household. So it would need uranium in the size of 2.5 packages of milk running one winter day Gösgen. It equals 180 lorries with oil, same with gas, 115 railway carriages with coal, and then, I don't know, 4 times Grand Ixence, which is our biggest hydropower plant, and 2,000 times the largest solar panel fields, which I don't know where it is, somewhere in the west, and then some wind energy. And this is the problem. Alex drags me around the whole world or whole Europe all the time, and we were in Vienna driving to Bratislava, and I was shocked. It was full of wind energy, and obviously people see this, and then they believe, it has to produce a lot of energy. And if you tell them that in Switzerland we have 1/3 out of nuclear power, apart from the people living in the canton of Aargau, they are surprised because you don't see it. That's the reason you don't see it, is you produce such a huge amount of energy with a limited space. And obviously, the higher the density of energy is obviously also the problem, maybe, that something can happen, because that's the effect of it, And it's a bit like, I mean, if you're cycling and you have a lack of sugar, what do and eat? Maybe not a salad, but something which has a high sugar content, because obviously you need energy. So then we want to say a few words about deindustrialization. It's a topic it's in everybody's mouth, particularly with our northern neighbors. So what is it about? I mean, some of it makes sense, because we are deindustrializing our nation since maybe decades, because our infrastructure is mostly built. So the steel consumption per capita is rather declining, but obviously in countries which are not built yet, which Carlos showed, you have a very low consumption per capita of steel and all those things. So the steel industry is moving to these countries. It first moved to China, now it's moving to India, and so on. But let's take aluminium, which is a product which is pure energy. Switzerland, according to statistics, has net imports of 215,000 tons of aluminium. So we export some 80,000, import 300,000. So we are not an aluminium-intense economy, because we obviously don't have automotive industry or aviation. I don't know, mostly it's probably packaging, I guess, and maybe some high-end products which we re-export. Doesn't matter. So these 250,000 tons, when a ton of aluminium is said to use 17,000 kilowatt hours, Gösgen produces 8 billion kilowatt hours. So the Swiss aluminium consumption is equivalent of half of the annual production of Gösgen, which is 20% of the households. So it's just, these products are incredibly energy consuming. And of course, we are happy that we don't have to produce it ourselves. We import it from Russia and China, which are the two biggest. But if they don't export it anymore, we would never be able to produce this because we don't have the energy for that anymore. So now I have a few processes. Aluminium, it's always the same. You have a mining process, which is obviously using trucks, etc. And then you often have electrolysis, so I don't know if it's correctly spelled, which uses a lot of energy. And all the industrial processes at the end are the same. You need temperature and need pressure. And it's why so energy intense. And this is not something you can change. By the way, a nice thing about these rare earths here, you see in producing alumina, first you get red slag, and 75% of the aluminium production is in China, 7% in Russia. And gallium, which people come to me and say, yeah, gallium is an interesting commodity, have you ever heard of? And I said, so, yeah, I know, but I don't have a clue. And it's being said to be used in, 5G and whatever, and we know that 75% of these rare earths, where nobody knows what it is, comes from China. Here is an example. Gallium comes from China because the aluminium industry is in China. And we have here the red slag, and therefore this byproduct comes out of China. Same is in vanadium. When a guy comes to you and says, I have a vanadium project and mine, call the police because he's a crook. Because vanadium is produced out of steel slag, or for example, Glencore's chromite smelter. It's not a primary mine product. So this is maybe the discussion about Russia. This is an interesting dam. It's Krasnoyarsk. This production goes directly to the aluminium smelter of Ian Plus, of Rusal. Ian Plus is the biggest aluminium producer ex-China, 7% of world market. China is over 70%. And it has two divisions, Rusal and the hydropower division. It produces 7% of all Russians' electricity with hydropower, and these 7% go directly only into the aluminium production of Rusal. Russia is a big country. It has an energy mix of a third, nuclear gas and hydro. Taking a third, it's already a third of all the hydropower goes to just the aluminium smelter. So it shows a bit how energy intense this is. Steel, so I thought I run a steel mine in China. I don't start producing steel or copper cathodes because it would be probably a bit problematic because I would anyway mess it up. But you need a 2000, I think over 2000 degrees, and your oven at home is a tenth of it. So we'll never get such high temperatures with, for example, the normal oven, the electricity. It's even a problem already in the pizzeria, no? Because with these modern ovens, you don't get a good pizza because you need to have higher temperature. That's the reason why you can't eat pizza outside of Naples, probably. Cement in Switzerland, the discussion, you need 1400 degrees for producing clinker. You don't get 1400 degrees with something which has no density of energy. That's the reason why Holcim or the cement production is so CO2 intensive, because it needs the energy and the heat. So, you can stop consuming cement, or maybe you build the hydropower dams with biomass, or who knows. Then ammonia, a product probably nobody has ever heard of, or many people have never heard of. It's going into the fertilizer. Did you know? It's surprising. The global ammonia production, BASF in Germany, you might have heard the problems about, the issues with gas and electricity. It consumes around 2% of global energy. 2% of global energy. That's more or less the same like the whole aviation industry. Just goes into the ammonia production. And without ammonia, probably the agricultural yields is being set to go down 50% plus, which is obviously then correlating with the world's population. That's a bit the chart Carlos showed, that the world population correlates 1-to-1 with the availability of energy. Fertilizer is pure energy. It's natural gas, nitrogen. And then I come to maybe the things which we say now, the new technologies and stuff like that. So wind energy. wind energy has, I think, is being said, some Greek guy like Heracles invented it, and the first yielding windmills were in Persia, 9th century after Christmas. And why hasn't the industrialization not happened with wind energy? It's the oldest thing in the world. And I mean, the title is because of Don Quixote. I have to excuse to my Spanish friend that I didn't read Don Quixote, but I have in mind he didn't won against the windmills. So it's not probably the fault of Don Quixote that we don't have the industrialization made with wind. And it was 200 years ago, or not a bit less, 150, in Scotland, when the first guy had a windmill and a battery and stored energy in this battery and provided or wanted to provide some of it to the local town. So why hasn't it been developed further if it's such an obvious thing? Human beings are not stupid, no? Usually if something works, then it goes quickly. That's the combustion engine. The handies, you know, I hate it, but I have one. How did Apple need any subsidies until you get a penetration of 100% in the world? Probably not. First solar panel was invented surprisingly same time, no? 1880. Obviously the productivity was horrible, and with investments it gets better and so. But strange is when Lindbergh flew over the ocean, then it stopped. It didn't develop further. Then we never flew over the ocean again and become more economic. It's strange, no? Why wasn't it used more? The combustion engine is much younger, no? But it went quicker. Hydrogen, it's an interesting thing. Now everybody talks about hydrogen. I think it was the first time produced in the 16th century, and it's produced mostly by natural gas. Of course, hydrogen is complete bullshit for energy, because the efficiency is 30 to 90%. What makes sense is that you have energy from wind and solar, which you can't use, and then it's a sort of storage. But the only way to produce hydrogen is dividing the water and the oxygen, and you need natural gas to do this, or another source of energy, but it's not a form of energy in itself. So everybody talks about it. I mean, see, being said here, the first fuel cells, 1840, the electrolysis process more than 200 years ago, which we use today for many things, copper cathodes, aluminium, what I said, hydrogen from green hydrogen stuff. Why did it take so long if it's so good? If you look at the biggest hydrogen producer, I've listed them left. I mean, you can buy funds like ours, no? It's Nutrien, the biggest fertilizer producer, Shell, Air Liquide, Koch Industry, which is like a Glencore in Germany. It's the second big, in the US, it's the second biggest non-listed US company after Cargill, something similar. Icahn Industries, which is Carl's Icahn, which is invested in oil companies. Linde, then Aramco, Kuwait Petroleum, Qatar, Sinopec, one of the two big state-owned Chinese energy companies. Gazprom will become the largest hydrogen producer. Unfortunately, the pipeline to the west is gone. Now they export it like everything to Asia. Rosatom, EDF, you know, it's all going on. C&Q, a position in ours, it's one of the biggest hydrogen producers in the world, because these guys have stranded gas somewhere in the out of nowhere in Alberta, and you can't use it, so you convert it into hydrogen, or the oil industry is flaring a lot of gas, which is obviously a waste. So instead of flaring, you convert it into hydrogen, which makes sense. But it's not the basis is not the hydrogen, it's the natural gas, or the wind, or the solar, which is very small. But then some other examples to the end. Nuclear fission. Marie Curie discovered nuclear, what's called, radioactivity in 1911. So you see, that's quite young, no? And then she was obviously using it for X-rays, or developing for X-ray, whatever. And then the nuclear fission was discovered 38 in Germany, only 38. I think by some Austrian lady, Jewish, which then had to flee Germany. So maybe that's not a good, if you want to become a dictator, it's not a good advice to try to get rid of the brainiest people in the country. So that was 38. 4 years later, the chain reaction was discovered by an Italian. 42. 3 years later, I think it was, the nuclear bomb detonated already. I mean, this is quite, not hundreds of years, 3 years. 54, the first nuclear reactor was connected to the grid in Russia, or in Russia, and 56 in the Western world in England. So this went pretty fast. So it seems when something really is working in terms of energy density, things go fast. And maybe it will remain like this. So that was my...
We have time for one question to Urs, if you want. Otherwise, he for sure will stay for lunch as well. Thanks a lot, Urs.